When multiplying complex numbers, it's really important that we start by looking at the simplifications of the powers of I so that we are able to leave our answers in the simplest form and in a plus bi form. Now recall that when we found out and got some information about complex numbers, we started with having the square root of -1 replaced with I in the definition. And actually, we need to make sure that we have defined values of our powers of I so that when we do our work, we get a unique answer for multiplication problems. Well, if I were to raise both sides of this equation to the second power, I'd have I squared on the right-hand side. And on the left-hand side, we would be looking at the square root of -1 raised to the second power. Now here, there is a property that we had for when expressions were real that we can't use when we have our expressions that could be our imaginary values. When we have our expressions that are imaginary values, we have to follow the part of the rule that said if you have a square root and you're raising it to the second power, you get the quantity that's inside by definition, so that we do have our unique values for our powers on I. So here we're going to say that I squared is worth, then the squaring of the square root just leaves me that -1. So I don't have the flexibility of either powering first and then taking the root, or taking the root and then doing a power when I have an imaginary. I have to look at using the power to the square root to get my correct definition of I squared. Now once we have that, then the rest of it we're going to follow through by looking at what happens when we multiply both sides of this expression by I again. Well, I times I squared is a base times a base to a power. So we'll keep the base and add the exponents. That'll give me I to the third. And I times -1 will give me -I. If I multiply both sides of this equation by I again, I times I to the third will be I to the fourth. And I times -I will be a -I squared, but we see earlier that I squared is worth -1. So that'll be the opposite of -1, which gives me a +1. Now within this, we like to think of these as our powers of i's that we can simplify. And then as we keep going, we'll see that it forms a pattern that keeps repeating. If I multiply both sides of this by I again, I get I to the fifth is equal to I. If I multiply by I again, I get I to the sixth is equal to I squared, but I squared is equal to -1. So do you see how this pattern is emerging and it continues on? So let me rewrite these without the work of how we've come about the simplifications and just give the simplifications themselves within these lines. So the square root of -1 will replace with I. I squared is -1. I to the third is -I. And I to the fourth is 1. I to the fifth is I to the sixth is -1, etc. So here, between these four, it just forms a pattern that will keep repeating. So let's say I want to find I to the 27th. Well, you could think, well, since it repeats, this would be I to the first, I to the second, I to the third, I to the fourth, I to the fifth, I to the sixth, to the seventh, to the eighth, to the 9th, to the 10th, to the 11th, to the 12th, to the 13th, to the 14th, to the 15th, to the 16th, 17th, 18th, 19th, 20th, 21, 22, 23, 24, 25, 26, 27th. So I finally get that I to the 27th simplifies to the opposite of I. That's a lot of work. There's an easier way to get to what line our simplification will be. See, we have 4 unique values that we get for our simplification, and then it starts to repeat again. So since it starts repeat after there are those 4 values, I can just take the exponent that we're raising I to and divide it by 4. That would keep track of how many full cycles we went into. And then it's the remainder, it's where we landed on that last time through after the full cycle that will give us our simplification for I. So if I take this exponent 27 and divide by 4, we have 6 times 4 is 24, subtract, and we get a remainder of 3. So I went through 6 full cycles of 4, and on that last one, I ended up on the 3rd line, or got my simplification, that it is our negative I. So it's the remainder that tells you how to do the simplification. Okay, now we can use this when we're multiplying. And so our next segment on multiplying complex numbers will look at how we might use this idea in order to carry out a multiplication of 2 complex numbers.